Okay, this lecture goes along with Chapter 10, Section 1, and we're talking about simple interest and promissory notes in this chapter. So the basic formula you're going to use forever is going to be the simple interest formula, which is principal times rate times time. And the thing to remember about this formula is that time is always done in years. So it's going to be dealt with in years always. So if it's like 3 months, it's going to be 1/4 of a year. 4 months would be 4/12, and so on. Second piece of the formula puzzle is maturity value, and that is that the principal is times by 1, which gives the value of the principal, plus the rate times the time, and we'll play with that formula here in a few minutes. But these are the two formulas you're going to need, so write those down in your notes so you'll have them. So let's see how those work. Pretty straightforward. Principal times rate times time. So if we have our calculator here, principal is 75,000. We're going to change the rate. 3/4 is going to be 0.75. Remember, we're going to move that over, so move 1075. So we're going to times that by 1075 times 6 months. 6 months is really half a year. So we're going to change that to 0.5. And we're just going to multiply that through. So our answer then, whoops, we need to move it on this side, is 403125. Okay, so it's all formula, it's all calculator, no tricks, just applying the formula. So because of one of the months ones, I'm going to do one of your normal homework ones here to kind of show you how that works here. So let's get the formula ready. So it's principal. So principal times rate times time. So 6440 times, we're going to change that half to a 0.5. Move it over 2. Okay, and 7/12. Because remember, it's time in years. Okay, so 7/12 it's months, so that's 7/12 is now in years. So now it's just calculator. So 6440 times 0.055 times 7, because we're going to assume that this is kind of like all over 1, okay, divided by 12. And then you can just plug it right into the calculator there. And they're going to round up on this number, so it's going to be 206.62. This 66 is going to round up to that 2. All right. So again, it's pretty straightforward. So what if we have days here? Next part of the chapter here in the second section actually, is they're asking you to do interest in both exact interest and ordinary interest, and the difference has to do with the number of days. Exact interest is in 365 for the full year, and the ordinary interest is based on 360, the number of days. So they want you to do it both ways. So let's see, we can get the calculator in there. I'm going to slide that up a little bit so you can see the calculator in the bottom. So we're going to clear this out. So we have 1,84500 times, we're going to change this to a decimal, 0.0775 times 58 divided by, we're going to do exact interest, 365 first. So you just plug it straight in and that'll give you your number you need. So we have 2272.13. Okay, and then we do the same thing times, again this is 0, so nothing's changed here, times 58 divided by 360 this time. And we get just a little different number. And that 75 is going to round up to that penny, right? So that's going to be 38, because they're always going to round up. Okay? Any questions? Okay. So again, it's just plugging it into the calculator. Oh, I know why. The number didn't look right because I had a misprint. So let me fix that for you real quick, because you're going to say, no, wait a second, that doesn't match my answer. Times 0.775 Oops. Clear that out again. I'm trying to go too fast now. Times 58 divided by 360. There we go. That looked right. I said, now how can you have just slightly more interest here? And that 78 is going to round up to that 69. There we go. That made no more sense. You know, as you get used to doing these, you're going to look at numbers and say, no, wait a second, that can't be right. It's got to be more interest than instead of less, so you can kind of check yourself as I missed a 7 there when I put it into the calculator. Okay, let's do another one of those, because these are kind of interesting. So number 10, we have $7,230 times, we're going to remember to change this to a decimal, right? 0.09 times, only 18 days this time. And we're going to divide that by 365 to start with. So we're going to get 3209, because we're going to round that. Okay, and then we do the same thing. Go back to our original numbers here. So we had 7230 times 0.09 times 18. And this time we're going to divide by 360. So, and then we would get 3254, because we're always going to round up. Just a penny. Okay? Now they're asking you to find, in number 18, they're wanting to know the maturity value and interest. Number 18 is also asking for the number of interest. So they want you to find the interest and then the maturity value, okay, of this loan. So again, we're going to get it ready. So we'd have 12500 times, half's going to go to 0.5, so it's going to move it over to 125, that's a decimal, and then we're going to go 5/12 of a year. Okay, so the interest then, do we see that? 125,000 times 0.125 times 5 divided by 12. Okay, and the interest is 6510.42. Okay, and then they want you to apply the maturity value formula. Okay, and I don't have a lot of room to write, so I'm going to write up here. So remember, the maturity value formula from above is interest plus rate times time plus 1. So here's the rate and here's the time. So in order to do this formula, we got to do this back part first. So we have 0.125 times 5 divided by 12 equals this number, 0.05208333. Okay, and then we have to add the 1 to it, plus 1 equals, and now we're going to times that by the principal, which is this number. We're going to times hit equals. So then we would have 131,540.42. Now you notice the answer is the principal plus the interest is the maturity value. Okay, so if you already have figured out the interest, just add it to the principal, and you don't have to do that back into the formula. So depending on what they're asking for, and you know which way to do it. Number 24, though, they're just asked for the maturity value, so we have to use the formula. Okay, so let's get it ready. So 18,620 is principal. This is going to be changed to a 0.5, so we have 0.105. And 30 months is really 2.5 years, so I'm going to make that 2.5 for years. Okay. So now applying our formula up here, we have the rate. I'm going to get my calculator back up here. 0.105 times 2.5 equals, okay, now plus the 1, All right, so we've done our formula. Now we're going to times it by the principal. So times. So 23,507.75. 23,507.75. Okay, it's pretty straightforward. They're not trying to do anything tricky. You just have to apply the formula and make sure you plug in your numbers right. Like I goofed on that one there a little bit. Just make sure you don't have fat fingers or miss a number. So let's look at how to find number of days in a loan or the maturity date. That's on the next page, or actually the bottom of page 311 and then the top of 312. So determine the number of days in each loan. Basically, you're just going to your calendar. So we have a loan date of June 27th and a due date of October 15th, and we want to know how many days are in there. Well, basically, we're just looking at the month. So in June, we have 3 days to get to June 30th, 27 to 30. So July, there's 31 there. Okay, August, another 31. September, there's 30. And then it looks like we have 15 days in October. Okay, so we got 5, 10, carry the 1, 100, 110 days. So it's pretty straightforward. You just have to get out your calendar and make sure you've got your months of the day right, and you're set to go. So here they're doing it a little backwards for number 36. Loan date is the 5th of February. There's 110 days, and they're wanting to know what day is it due. So it's the same process here. We have to get up to 110. So February to the end of February is 28 days. We're not going to worry about leap years, so we're going to call February then 23 days. Well, March, abbreviate there. There's 31 in March. Okay, April, there's 30. So we're starting to get up there a little bit. So let's go ahead and total how many we have then. So there's 4, there's 84 of our 110. So we're getting pretty close. So let's go ahead and subtract that. That's in 6, 26. So it looks like then it's not quite a full month, so it looks like it's going to be due then on May 26. So you're just counting how many's left in each month and just kind of going along by month until you get to the number of days you need, writing it down. Okay, so there's a lot in this section. It's mostly formula driven. You just have to be careful as you're applying to the formula. Remember, back up in here when you're looking at these, the critical thing then is time is always in years. All right, so it's in years. So don't get fooled by 7 months and putting 7 in and do it. You have to do 7/12. Okay, so just be careful, but have fun.